Hello viewers, welcome to this video on speed and distance problems. The video is presented by the Postgraduate and Research Department of Physics of National College of Tiruchirappalli. Both the department and the college feel happy in presenting this as an e-resource to the aspirants of UGC-NET, CSIR-NET and GATE examinations. This is Dr. T.V. Sundar explaining you the concept of speed and distance with some illustrations. Let me start with the basics. Speed of an object or a vehicle is defined as the distance traveled by it during a particular duration of time. That is, speed is equal to distance over time. From this we can derive the other two parameters, namely distance is equal to speed multiplied by time and time is equal to distance divided by speed. The first one is a water filling problem. The graph shows the volume of water filled inside a conical vessel as a function of time. So it is given that an inverted cone is the shape of the container in which water is filled at a constant rate. So the curve in the graph which represents the process is to be determined. To find the solution, the hint is given in the question itself. It is given that water is poured at a constant rate. So the variation of filling up of water with time will be a linear one, which is represented by the curve named B in the graph. Hence, option B is the answer. As an additional information, remember that the formula for the volume of a conical object is 1/3 pi r square h cubic units, where r is the radius and h is the height of the cone, and L is known as the slant height of the cone. This one is the second problem. Two persons A and B start from the same point in opposite directions along a circular track simultaneously. Speed of B is 2/3 that of A. How many times will A and B cross each other before meeting at the starting point? This problem is based on the concept of least common multipliers of numbers. However, the solution needs a little bit of thought process. You refer to the figure where the circular track is represented. Let S be the starting point where A and B start in the opposite directions. That is, A in the clockwise direction and B in the counterclockwise direction. Since the speed values etc. are not given, let us arbitrarily take A's speed as 60 meter per second and B's speed as 40 meter per second. Since he runs at 2/3 of the speed, automatically it comes out to 40 meter per second. And A moves in the clockwise direction and B moves in the anti-clockwise direction. Also, let us take the perimeter of the circular track as 120 meter. These figures I have arbitrarily taken. These can be of any value. They can be multiples of these two also, but the analysis will get lengthened. Now, let me construct a table that is a time lapse and distance covered by A and B when they traverse the circular track. So the table gives the progress of the persons at a 0.5 duration of 0.5 seconds, and A completes the distance is 0, 30, 60, 90, 120, etc. Since he moves at 60 meter per second, and B in 0, 20, 40, 60, 80, etc. since he covers the track with a speed of 40 meter per second. Now from the table we can see that after 6 seconds they will meet once again. At t equal to 0 they are meeting, and they start their journey in opposite directions, but only after 6 seconds they will meet again. But at that time of 6 seconds A has traversed 360 meters, that is he has completed 3 rounds, but B only 240 meters, that is 2 rounds only. Now in between this time, how many times they would have met each other? Now again refer to the figure. So A is moving in the clockwise direction and B in the anti-clockwise direction. So half of the track coverage by A are written in red color letters. So 60, 180, then 300, and that of B in black color letters. So 40, 80, etc. So from the figure itself, we can see that 4 gaps exist between these two persons. That means 4 times they meet each other before the completion of 6 seconds, and is the answer. The third one is based on the flow rate of a fluid. An intravenous fluid is given to a child of 7.5 kg at the rate of 20 drops per minute. The prescribed dose of the fluid is 40 ml per kg weight of the body. If the volume of the drop is 0.05 ml, how many hours are needed to administer the dose? Let us find the solution step by step. First, let us calculate the dosage required. Fluid to be given in milliliters to the child of weight is 7.5 kg at the prescribed rate of 40 ml per kg is 7.5 into 40, 300 ml. Rate of flow of administering the fluid is 20 drops per minute, that is 20 into 0.05 ml per minute, that is 1 ml per minute. Now time required for giving the dose of 300 ml is equal to 300 by 1 equal to 300 minutes, which is nothing but 5 hours. So option D is the answer. This is a track running problem again. On a track of 200 meters length, S runs from the starting point and R starts 20 meters ahead of S at the same time. Both reach the end of the track at the same time. S runs at an uniform speed of 10 meters per second. If R also run at a uniform speed, what is R speed? To compute the answer, let us draw this rough diagram. The track is a linear one with a length 200 meters. So S starts from the one end of the track, whereas R is 20 meters ahead of him. That means S runs the distance of 200 meters, whereas R covers a distance of 180 meters only. Both start at the same time and end at the same time. That means they done at different speeds. Speed of S is given, whereas that of R is to be determined. It is also given that both run at a uniform speed. Now recall the formula. Time is equal to distance by speed. Therefore, time taken by S is equal to time taken by R. That is 200 meters by 10 meters per second is equal to 180 meters by R's speed. Solving the equation, we see that speed of R as 9 meters per second. And the option is A. The final one is a graphical question. Given plot describes the motion of an object with the time. Which one of the following statement correctly describes the motion of the object? Actually, the graph is not a distance versus time graph. Please note it is a velocity versus time graph. So we need to verify the correctness of the statements and pick out which correctly describes the motion. Now look at the graph carefully. The velocity attained by the object, exactly the 1 hour intervals are depicted there. The variation is a straight line passing through the origin also. So its slope is 45 degrees, but it doesn't mean that the acceleration is constant, because it is a velocity versus time graph. It indicates that the object attains a speed of 100 km per hour at 1 hour, 200 at 2 hours, 300 km per hour at 3 hours, and 400 kmph at 4 hours. That means the speed is increasing at every 1 hour duration. Therefore, the object gets accelerated, and is the correct statement. The other three options are false statements and can be verified from the graphical data. So students, hope you enjoyed these problems. Let me discuss similar problems in another video. Thank you.